Hello everyone, this is Aditya, and today we'll see how to derive Schrodinger time-independent wave equation. So let's start with the lecture, but before that please do like, share and subscribe my channel. And now let's get started. Okay, so now let's start. So we all know a general form of wave equation. Generally we write it like this: psi is equal to a raised to the power I of kx minus omega t. Well, I won't discuss about it right now, but just remember that many a times we write it in this form, right? And we can also write this as psi of x comma t is equal to psi of x into a raised to the power negative omega t, right? Like this also we can write, okay? So now let's see from this how do we derive Schrodinger wave equation. And we know that energy, the total energy is equal to the sum of kinetic energy plus the potential energy. We all know it, right? Okay. And we know that kinetic energy is equal to half mv square, right? Okay. We can write it as m square v square by 2m, right? And notice that mv is equal to the momentum. So momentum square by 2m, right? Okay. So we get the kinetic energy as p square by 2m. So we get E is equal to P square by 2m plus U, right? Okay. Let's assume this as equation number 2. Okay. So now we know that psi is equal to e raised to the power I of kx minus omega t. You can use this form only. It will be okay. Okay. So now what you do is you differentiate it with respect to space. You get ik e raised to the power I of kx minus omega t, right? You solve it. It is a very simple differential, right? And now take the second derivative, you get this expression. Solve it, you will understand how, right? Notice that it is equal to ik of psi, right? Okay. So just see, you have got this expression. Now what is k? K is the wave vector and k is equal to 2 pi by lambda, right? And we all know that momentum is equal to h by p, right? Okay, h by lambda, right? Okay. So you get lambda is equal to h by p. Okay. Now just substitute this. Get 2 pi by h into p, right? Just substitute, you get p by h by 2 pi, which is equal to p upon h bar, right? Okay, you all know this. So you get k is equal to this quantity. So you get del 2 psi by del x square is equal to this expression negative k square into psi, right? This was the expression. And you get negative of p square by h bar square into psi, right? And notice that in this I have not used just the differential sign, I have used the partial derivative. Why? Because the psi is dependent upon two variables, x and t, right? Space and time, right? That's why. Okay. So from this, let's assume this as equation number 3. And we know that energy is equal to p square by 2m, right? Plus u, right? You know this. Okay. So from this, what you can do is that you can say that E is equal to P square by 2m plus U. And from this, you can say from the equation number 3, you can say that P square psi is equal to negative del 2 psi by del x square, right? Del x square into h bar square, or rather you can say p square is equal to this quantity. Okay, so now let's substitute this quantity over there. Okay, so let's see, you get E is equal to negative del 2 psi by del x square into h cross square by psi plus u, right? You get this expression, right? Now you get E psi is equal to negative del 2 psi by del x square into h cross square plus u psi, right? Okay. So just bring everything to the LHS, you get E minus u into psi plus del 2 psi by del x square into h cross square is equal to 0, right? Okay, and let me see if I made any mistake. Yeah, I made. It will be upon into 2m also, right? Okay. Upon 2m. You get upon 2m. So basically the expression is E minus u into psi plus h bar square by 2m into del 2 psi by del x square is equal to 0. And this is Schrodinger time independent wave equation, whatever you want to say the acronym. It is just for it was just for fun what I wrote. But this is the expression, right? So I hope you understood the proof. So please do like, share, subscribe my channel, and thanks a lot for watching my video. Bye bye. Take care.